this over here. I don't need that on that screen. Preparation streaming del vivo per union. Okay, so that seems to be sort of doing some stuff. Let me just see if this will open. Okay, right. Now, okay, right. Let me just. I just wanted to show you something because I've been playing with idiot. Come on, there we go. Right now, too many things going on. I can't see the mouse. Where's the mouse? There we are. There we are. Right. Okay. Yeah. I've been playing with a microscope, and I went hunting the other day. This was the other day. It was about a week or so ago, and I found some interesting things. Let me just move this up. There we go. Right now, I'll just wind this back. I got some samples from the garden in, I think it was September, October time, and I've just kept it in a jam jar in the kitchen, and it's from under the plant pots. Oh, I don't. Right. Okay. So let me just. Okay. Right. Okay. So, I've had this. I've had this thing. I'm calling it the aquarium, because I don't really know what else to call it. And I'm basically looking to see what sort of animals I've got in there, and I was particularly looking for amoeba, because they're actually quite difficult to find sometimes. And I was looking and I was looking and I was looking and I couldn't find, I could see all sorts of other stuff. And then all of a sudden, as I was looking at these diatoms here, and all of a sudden this guy arrived and he just crawled across the field of the microscope. And here he is. This is the amoeba. Have you seen this? How all of its cytoplasm moves around as it crawls. There's a vacuole in there, and there's all sorts of bits and pieces that these are things that it's been eating. But it's really quite fascinating to see. What do you think? This is one of the reasons why you should never drink pond water. You definitely don't want this in. You don't want this in your stomach. So what do you think? What do you think of this?
Can I ask you, what are all the dots and spots we see? Is it inside it?
Yeah. This is right. So this is the let's say the boundary of the animal or of the cell. Okay. And what we've got inside, you've got some clearer areas. These will be like the vacuoles of various different types. But these dots, these are things which it's in the process of digesting. So there's lots of in this water. There's lots of oh God, what are they called? There are a lot of diatoms, and there are a lot of algae. And some of the algae are quite small. They're sort of small single-celled algae. And what it does is it just basically eats them. And what it's doing is it's just moving along. It's hunting around for its food, and these things are, let's say, what it had for dinner. But what I found fascinating about this whole thing is that, like, when you have these other animals or these other cells, these other organisms, like this is I think it's a diatom. It's an algae. It's static. Okay, the thing itself moves around, but inside it's static. Whereas, could you imagine sort of walking down the street as like a blob, and you sort of like your liver's sort of like all over the place, and then your heart, you're just sort of all getting mixed up inside. It's a bit weird. just a bit weird. And then it comes across the surface, and it sort of moves along. It's moving along the surface for looking for the next thing to eat. There's that vacuole moving
a bit disgusting.
It's life. It's life.
The magic of life.
Yeah, this is where it all started. So that was one thing.
But it gives contribute to purify the water. No.
Well, yes. I mean, it's certainly. Let's see if I can pull this guy up now. I mean, these, because basically what they're doing is they're just they're just eating whatever they can find. So obviously, if the water is too polluted, then they won't. Then these things won't survive. But this is one which is, it's called a bdelloid, and it's sort of like, it's a bit difficult to see here because I've got it just at the right angle. Basically, it's like a cup shape, and it has a sort of like it's sort of this sort of shape, and it has like well, I wouldn't say it's a tail, because it's not. It's like something which it uses to anchor itself onto surfaces or whatever. Okay, so I'm drawing something and you can't really see it, but basically what it has is it's got a whole pile of cilia around its mouth, and its mouth is here. Okay, and what it does is it waves these things around. These things move, and the food gets pulled into or in towards its mouth. It's really quite it's quite fascinating to see. You can just about see there's a sort of a refraction fringe here. This is the ring. It's like the crown of these cilia, and you can sort of see there's movement here, and this is because it's moving the particles. There it is. That's the ring. That's the ring. But the cilia themselves are quite difficult to find or to see, let's say. But you can see that there's sort of pieces are really flying around, which is, it gives you the idea of how powerful these things actually are, because they're like motors. These things are like motors. And if you think about the size of this thing, now this is 800 times. If you think about the size of this thing, which is, it's pretty small, the viscosity of water is such that it's like as if you were sort of swimming in a vat of, or in a swimming pool full of molasses. Okay, imagine how much energy you would need and how much force you would need to be able to move. It's really quite incredible pieces of there it is. It's opening up, and let me just oops. I'm just going to pull that back to the beginning, because I think it was at the beginning that I managed to catch it most of all. Best of all, echo. Here we go. Right, here we go. There it
Gordon,
is.
I have a question.
Yeah. Yes.
Do you need any color to see clear this animal?
Well, you see that the problem. No, that's a good point. This is just natural. Okay, this is a drop of the solution, and that's it. Because the thing is that if you start putting the dyes in, you start killing them. So you typically use dyes when you've got at least the sorts of dyes that we can use at home, let's say, that you can get hold of easily. You would typically use, like the pink colors or the fuchsin or whatever it is. You would typically use those, or the methylene blues and stuff, on static samples, static specimens. Yeah. Okay. having said that, if you root around on YouTube, and I'll just write this on the thing. If you have, there's some fantastic stuff out there, and in particular, if you look for fluorescence microscopy, there is some absolutely amazing stuff that people do. But obviously, you're talking about like really, like research, university research labs and stuff, and they use colors and dyes to see what's going on at the level of the organelles in the cell, and it's some amazing, really quite amazing stuff that people do with this. So yeah, so this is a bdelloid, which is one of the more unusual words I've come across in the last couple of years. Of bdelloid. Oh yeah, and I've got. I wanted to show you this one as well. I've got a few. I've got a few of these. Videos, just a couple of seconds basically, but I thought this one was nice because this one I managed to catch this guy, and I don't know what he is. I think he might be a paramecium, I'm not sure. He is coming, don't worry. Here he is, there he is. Now this one, it looks like a cucumber. But if you look around first of all, what you notice is that you've got this sort of shape, which is like this, and you've got these like, just like a cucumber, basically like stripes on it. Okay. But if you look carefully as the video goes, you can see it's this sort of shimmering. Yeah. It's like this sort of, it's like they're fluctuating. And this is because these are rows of cilia. So this thing, it's like a hairy cucumber, if you like, and it's these are the rows of the cilia which it's using to swim and to move around. Now, I think at some point he turns around and he actually shows us his mouth. But you can see he's sort of he's got this like tumbling motion, and this is because of these cilia. Now, come on, I think he turns around at some point. Yeah, maybe now. Maybe. Yeah, there he is. Right, okay. His mouth is around here. So it's like a sort of like it's like a tube. It's like a tube, if you like. There you go, you can see. And the other thing is that because of with the cilia, what they have is these stripes, compared to the amoeba, which was all sort of basically like a sack of jelly. This means that there's structure, and they have a cytoskeleton structure to hold everything in place, which is I think it's really quite cool. So I found this guy sort of zooting around in the pond, or in the aquarium, I should say. And then the last one is let's see if this one will work. Let's see if this one will work. Let's decide. Okay, it's a different. Why is it using a different player? I don't know. Let's just see if this will work. Maybe. Maybe not. Anna's. Oh, there they are. There they are. Right. This is what's called a lacrimaria. Now, this is me changing the objective on the microscope, and now I'm sort of zooming in, trying to find him again. There he is. There he is. Now, if you notice, he's got like it's not a cilia. it's actually like a proboscis. He's sort of like, he's this sort of shape. I'm saying he, it might be a she, I don't know. But they use this. I found out that they use this to hunt. Here's another one. There you go. You can see he's got this. Now I don't know why they're doing this sort of like curling up business. It's a bit weird. But these are called lacrimaria, and they've got this name because apparently they supposedly look like teardrops. Okay, like they supposedly look like something which is when you're crying. So okay. Anyway, I just thought I'd show you that show you those things that which I found as I was playing with the aquarium. Okay, so what I thought I'd do today is I thought I'd do something about the weather and the atmosphere, and I've prepared some exercises which I thought might be a useful little bit of revision about the atmosphere, something along these lines. Now, who is this? Who have we got? Have we got someone else? This must be Marina. Ciao, Marina. Are you on the train? Are you on the train? Or are you in a... Okay. Right. So, okay. So what I thought we'd do is I just sort of thought I'd try these, try this type of thing. As you know, I've been using these sessions to try and play with different types of materials. I've used PowerPoint, and this is a web thing, which is a more interactive type of exercise. But as I say, I just wanted to see if this thing would actually, work. So I don't know. Does anybody feel like, Gloria, do you feel like you might want to try the exercise? Let's...
Yeah, sure. Why not try?
Okay, so now the thing is, what this has done is it's given me a choice. Okay, so rather than just having a completely open field, I've restricted the choices a little bit. Okay, so we can try. Okay, so
the Earth is surrounded by a gaseous atmosphere which protects the planet and enables life. The atmosphere is approximately 10,000 kilometers deep, although this does depend on the definition that is used. It is most dense closest to the surface and has 5 distinct concentric layers, which are separated by boundaries called poses.
Okay. Yeah, Sal, do you want to continue?
Earth's atmosphere is composed of a mixture of gases, and of which nitrogen is the most prevalent, 78%, followed by oxygen, 21%. The small percentage remaining consists of a mixture of carbon dioxide, argon, and other noble gases. The composition of the atmosphere has changed over time and has been affected by the presence of life on Earth, as well as volcanic activity.
Okay. Oh, you guys too good. Or this is too easy. Maybe. Okay, Livio, do you want to continue?
A layer closer to the surface is a troposphere, which reaches a height of 6 to 10 kilometers. It is also called the lower atmosphere, and this is where meteorological phenomena occur. It is also the region of the atmosphere which is densest and contains the air which we breathe. The temperature of the troposphere decreases as we climb higher. Since the Earth's surface absorbs a lot of energy from the sun, this is released and warms the air in the troposphere, creating strong convection currents, which make the troposphere very turbulent.
Okay. Right. Okay. Let's just check. Okay. I thought.
The nearest.
No. Yes, the nearest.
Nearest.
Yeah. Okay. So it was a little bit of a trick one there. Okay. And now we're okay. Yeah. So do you get why we have such variable weather? Why do we have such variable weather? Because we are down here and the troposphere is this sort of pale blue part, which is right next to the surface. So why do we have such turbulent weather or such variable weather?
There are differences in temperature. So convective circulation.
Yeah. Well, so okay. So yeah. Good. So Anna, are you there? Can you hear us? Can you say something? Hello.
Yes.
Okay.
Yes, I'm here.
Okay. So can you think about the surface of the Earth? What is it that, or what sort of, as Livio says, you've got temperature differences. So what sort of things might cause these temperature differences? Have you got any ideas?
No.
No? Antonio?
I have some ideas, but I'm not sure.
Okay, well, just try. I mean, this is just remember, it's not a quiz. It's just to get you talking. So it's.
I'm trying to explain my ideas. I'm thinking about gases in the atmosphere. They create I don't know in English, effetto serra.
Okay, it's the greenhouse effect.
Greenhouse effect, yes.
Okay, so
in this way, the sun put energy on the Earth, in particular electromagnetic waves, infrared waves, and they are reflected by the greenhouse gases, and they are trapped in the lowest part of the atmosphere. For this reason, we have an increase of temperature near the Earth.
Okay, yeah. I mean, that's certainly. Let's say certainly this is part of it. What do you know? Anything? Do you know the names of any of the greenhouse gases?
dioxide. I don't know in English. Yes,
Okay.
carbon dioxide.
Dioxide, yeah. Carbon dioxide is 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 a very strong greenhouse gas. Does anybody else know any others? As I say, this isn't supposed to be. It's not intended to be like a test. It's just a way of getting you to talk about stuff in sciencey sort of stuff.
Methane.
Yeah. Yes. Methane. Yeah, it's a very bad cow. Sorry.
Oh.
Okay. Yeah, methane. Methane is a much stronger. It's a much stronger greenhouse gas in terms of its effect than carbon dioxide. It has a shorter half-life in the atmosphere, but it has a much stronger effect. Okay. Yeah, that's one thing. Has anybody come across this word? Have you ever come across this word before? Albedo or albedo. In English, it is. That's what it is.
I don't know it.
No, I wouldn't. I wouldn't imagine that English teachers would normally come across this word because it is rather specialised. It's to do with absorbing energy by a surface. So it's literally the fact that something like a solid surface, which is dark, will absorb more energy than a surface which is light. So that's one aspect of it. The other aspect also is so this is to do with the energy absorbed, or the ability to absorb energy. So ability to absorb energy. Okay. But also you have heat capacity as well. You have if you think about the surface of the Earth, what is the surface of the Earth covered in for the most part?
Water.
Yeah, is it 2/3, something like that? Is it something like 3/4? I can never remember whether it's 2/3, 3/4. But so you have the difference in the heat capacities of the water and the let's say the continental part, the rocks, the solid part of the Earth. So you have all of these let's say pieces which sort of go together to create these different heat reservoirs. And so the heat these are constantly changing temperature as they absorb and then release energy. And as the Earth is turning, so it comes into the sun and then goes into darkness. You have the difference between night and day, the nighttime temperatures and the daytime temperatures, and all of this is happening very close to the surface. So it's happening in the troposphere, which is where you get these very strong convection currents. And just have to think about here in Verona during the summer when we look at the mountains and we see the clouds forming over the mountains. This is very much linked to absorbing the ground absorbing heat and then releasing it. Okay, so right, so we need to go a little bit higher. So Anna, do you want to try and do you want to take this a little bit further forward?
Yes, I do. Yes.
Okay.
In contrast to the troposphere, the stratosphere is quite stable,
Yeah.
and the temperature increases with the altitude. This heat is generated mostly by the oxygen-ozone cycle, in which ultraviolet light excites oxygen molecules, O2, which react with oxygen O atoms to create ozone, O3. Ozone absorbs UV light and breaks down into molecular oxygen and an oxygen atom, releasing a large quantity of energy as heat. This explains why the temperature of the stratosphere increases with altitude, despite the fact that the air is more rarefied.
Yeah, it's similar to the Italian rarefatto.
Yeah.
Yeah, no. In fact, one of the things that you will notice with this type of language is that it's not too different, and the idea. Oh, Ivo, we've got Ivo. Hello, Ivo.
Hello.
I can see you. I can see the top of your head. Okay, yeah, that looks good. So, I think, I don't know, does someone else have the idea that the stratosphere is way, 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 way high, way up there? Because I always thought of the stratosphere, it must be, it's almost, I wouldn't say at the edge of the atmosphere, but it seems to be really high, but actually it's not. It's actually quite close to the Earth's surface. So we have this, the ozone layer, which is actually fairly close. It's at the bottom of the stratosphere, and then we have the stratopause, which is at the edge of the stratosphere. As we're going further and further away. So okay, so let's see who wants to. Does anybody want to volunteer for this one?
I try.
Okay, vai Anna, vai.
The stratosphere starts
Okay.
Starts after the tropopause and extends out to about 50 kilometers. The ozone layer is situated in the lower stratosphere. Jets fly in this layer to avoid the turbulence in the troposphere, and meteorologists send weather balloons to this layer to study it. The temperature of the stratosphere increases from the lower up to upper stratosphere, but is still well below zero.
Okay.
Above the stratopause, the mesosphere. Wait, can look in the picture. Extends to about 85 kilometers from the surface. The air here is very thin and the molecules are far apart. What does it mean? Apart.
What does it mean? Okay, so if we say that the air here is very thin, what do you think thin air means?
Thin, sottile.
So we're not sort of talking about a layer, though, are we? We're talking, when we say thin, it's like there's not a lot of it.
Okay, I understand. So they are far.
Yeah. So
Not
basically,
close, not close because okay.
Yeah, because the molecules, there's a lot of space between the molecules.
Okay. Okay.
Yeah.
Would the opposite be dense in this case?
Yeah, the air here is very thin. You could actually say the air is thick. You could say thick. But the thing is, what we're doing here, Gloria, and that's a good point, is this very, very much a language teacher's point. You can use dense, you can use density, and you can qualify it as being less dense, more dense, okay? But obviously that's a comparative. You typically talk about thin air because, or the air has been thin because there's not a lot of it. Okay.
Oh yeah.
Okay.
Yeah.
Okay.
Okay.
So, okay. Thanks.
Okay,
Temperatures
Anna.
in the Mesosphere can reach 90.
Minus 90.
Minus 90. How can I read?
Degrees centigrade. Okay.
Degrees centigrade, thanks. It is difficult to study because weather balloons can't reach it while it is too low for satellites. The density of the mesosphere is too low to support aircraft, but high enough to make materials visible when they enter atmosphere.
Okay, right. So do you get? Does everybody get this part here? This idea of the this mesopause is difficult to study because it's neither full, let's say, full atmosphere or space. Yeah. So it's sort of like una terra di mezzo, or un'area di mezzo, if you want. So this idea that the molecules, obviously, the molecules are getting closer together, the closer you go towards the surface because of the effect of gravity. But in the mesosphere, there's not enough to provide the buoyancy for an aircraft. So an aircraft doesn't have enough to support its wings. But there are enough. There's someone else coming in. Let's just see.
Hi,
Rosella.
everybody.
Ciao, Rosella. Hello. So it's but there's enough molecules around. There's enough molecules around that when a meteor, a lump of stuff from space, comes flying into the atmosphere, there's enough gas to cause friction, and that will cause the meteor to burn up. Okay, so this is the mesosphere. Okay, so Ivo, do you want to carry on? Will you take this next one? Microphone. Hello? Microphone.
Hello.
Equity. There you go.
Okay. At the top edge of the mesosphere, there is the mesopause.
Pause, yeah.
Mesopause above.
Okay.
Above which we find the thermosphere. This layer reaches out to between 500 to 2,000 kilometers from the Earth's surface and is very much affected by the sun, which can cause it to reach temperatures of 2,000 degrees Celsius.
Yeah, degrees Celsius or degrees centigrade. Okay.
Centigrade. Okay. This layer is also called the upper atmosphere, and is where the aurora borealis and the australis occur. Oh, it's very interesting. Okay. Even though the molecules of nitrogen and oxygen in the thermosphere are quite far apart, there are enough of them to be strongly affected by solar radiation. Short wave ultraviolet light, UV, from the sun is extremely energetic and is absorbed by the molecules and the atoms of oxygen, releasing energy that creates higher temperatures at higher altitudes.
Altitudes, yeah. Okay, yeah, good. Okay, yeah, I mean, I think that was fairly straightforward. Okay, has anybody got any questions or comments about this part? Has anybody had experience of the aurora? Rosella?
No.
No?
Not yet. Maybe
Not
in the
yet.
future.
Ivo, have you ever had experience of the aurora?
But,
have you seen it?
I seen once something similar near the North Pole.
Uh-huh. What were you? Don't tell me you're not Santa Claus, are you? Non sei Babbo Natale.
No. Not yet.
Oh, yeah.
But maybe next year.
Okay. What were you doing near the North Pole?
No, but near the North Pole in Finland.
Uh-huh.
But some similar phenomena of aurora borealis, but not the true aurora.
Okay. Has anybody else, Livio? Have you had any experience of the aurora?
No, not yet.
Never seen it. No, so I've been incredibly lucky, I think, because I've seen it in Canada, I've seen it in Norway, and I've actually seen it in Scotland as well. Scotland is far enough north that when if you go sort of early summertime, late spring, early summer, and early autumn, if there's a lot of solar activity, if the sun is active, and it's sending out a lot of particles, charged particles, the more active it is, the further south it comes. So you can actually see it at quite low latitudes, and it's quite common to see it in the north of England and the north of Scotland. But it's even more common, obviously, if you go to places like Norway and Canada. But yes, it's definitely one of the most spectacular things that you can see. It just really is quite unbelievable. Yeah. So yes, that's the aurora, or the aurora, as we would say in English. Okay, and what about this next one, Rosella? Would you like to just have a go through this one?
Okay. After the thermopause, we reach the last layer of Earth's atmosphere, which is called the exosphere. The exosphere extends out to around 10,000 kilometers and is the part of the atmosphere where weather satellites are located. Yeah. There are very few molecules here, and there is no clear boundary between it and outer space.
Outer space.
Outer space.
Outer space. Okay. Bye. Do you want to continue?
Okay. In contrast to the other layers, which are more or less described, no, defined.
Okay, this looks
the
better.
ionosphere does not correspond to a defined layer of the atmosphere. Rather, it describes regions in the Mesosphere and the Thermosphere, where ionized particles are present. The the altitude.
Yeah, okay.
The altitude above the Earth's surface varies during
varies
during the day and in the season. The ionosphere is used in long-range radio communications, in which it can help to reflect radio signals around the globe.
Signals.
Okay, signals around the globe. An easy mnemonic for the layers of the atmosphere. The smart man takes the elevator.
Okay, we'll have a look at that in a minute. But yeah, so that's okay. Yeah, this is the ionosphere. I think we'll have heard of this probably. But curiously enough, it moves around. It's not so well defined. It's actually in both the mesosphere and the thermosphere, according to how many ionized particles are around. But of course, this part is useful. This idea of let me just sort of pull this down a minute. This idea of the long range communications, because the idea is that you have the ionosphere, which is ionized particles which have a particular behavior, and so you're actually able to use this to bounce radio signals around the world, which is pretty cool. I think that looks like a set of horns, doesn't it? Okay, yeah, good. So this is the exosphere. The smart man takes the elevator, and yeah, okay, I've got all of this is summarized here on this diagram, and so what would you say about the temperature? Do you find this rather curious? So we start off sort of quite low out down in the troposphere as we get to the top part of the troposphere, and it sort of gets it starts to increase as we get into the mesosphere, and it sort of gets it really increases a lot as we get into the thermosphere. This is really rather curious, I think, because you tend to think of it must get colder and colder, but of course this is the temperature of the molecules. This is the thermal movement of the molecules, because they're really flying around with a lot of energy here. Okay, so let's see where we go from here. Ah, right, yes, okay, I wanted to try this. Okay, so it's a little quiz. So the thing is, you have to tell me which dot you want. So if you'll have to describe it. You'll have to describe the position of the dot. So Sal, which
Gordon.
Dimi.
I can't read the words on the right.
On the right. Now, is that because this is too
I don't know
big?
why. Maybe.
Okay, let me just. Has anybody else got a problem with it? Are they too small? Are they okay? Is it the screen size?
For me, it's impossible to read.
They are smaller. Now they're smaller.
Yeah, okay. Now the thing is, are they fitting on the screen, or are they? How?
It's very small.
How about that? Is that any better?
Yeah.
This is better. Yes.
Okay.
Now
Okay.
it's okay.
Okay, Anna, it might be the size of your browser window. I don't know, because I don't know. The thing with all of this stuff is that you never know exactly what other people see. So we'll. Okay, so
I'm using Chrome in Windows.
yeah. Have you got it at full screen? Have you tried
Yeah.
to?
Okay, I tried to.
Have you tried to? God, what's it called? Ingrandire, to magnify it.
Magnifying, yeah.
You should.
I tried, but the problem is not the dimension of the font dimension. Is for me is the letters.
The letters aren't clear.
Yes, they are not clear.
Okay.
I don't know why.
I don't know. If does anyone else have the same problem?
No, I can see. I can see.
Okay, it could be a browser thing. Don't know, because the thing is, what this is my screen being shown through Zoom, so I don't know what sort of. Okay, let's go on with the exercise, and hopefully the next ones will be easier to see. Okay, anybody?
The external one.
This one
is a exosphere, of course.
Okay, so just put this one here. Okay.
And where borealis aurora happens are thermosphere.
Okay,
it's thermosphere. Thermosphere.
Okay, so this is the thermosphere and this is the aurora. Okay.
And
Rosella, I'll get. Sorry, thanks, Sal. Rosella.
Okay, the layer with
the layer.
The layer, yes, with the square spot. Yes, it's
this one.
This one is the ozone layer.
Okay. Right. Okay.
Okay.
Ivo. Microphone.
I need your help.
You need glasses. Is it too small? Okay, I'll try and see if I can make it a bit bigger the next time. Okay, so we've got mesosphere, stratosphere, and troposphere.
The stratosphere
is which one?
Is the
this one, or this one?
10,000.
This one?
No.
Yes. No.
Can we put it there?
1,000.
1,000.
1,000 kilometers.
This one. Oh, hold on a minute. It doesn't like.
No.
It doesn't like.
No. No.
It doesn't like it. It doesn't like it. This is Java. This is Java. Go away from it. Go away from it. Go away. Okay.
Okay.
Okay, right. Okay, so let me just put that one there again. It looks like the stratosphere really doesn't. It really does not want to. This is teething trouble. Let's see if I can get that. There we go. Right. Okay. Now. Okay, I'll tell you what. I'm going to reload the page. Okay, but don't worry. Right. So, where did we get to? We had the aurora is definitely over here.
Yes.
And we had the thermosphere. Where is it? It's definitely over here. Okay, now, Ivo, what were you saying? I'm sorry, we also had the ozone layer down here. What were you saying, Ivo? Mesosphere. Okay, where?
85 kilometers.
Okay, this one. Okay.
Okay.
Right. Okay. Livio, what do you think now?
On the right, lower on the right, there is troposphere.
Okay.
On the left, stratosphere.
Okay, which means?
And
exosphere is here.
Exosphere.
Okay, right. Do we agree with this?
Yes.
Hey. Okay. Now I've never seen that effect before, where it was like some sort of magnetism for some reason. I don't quite know what was happening there. Okay. Right. So so what I thought we'd have a quick look at now is we'd have a look at weather. Okay, and in particular we'll have a look at clouds. So again, I was thinking this morning there was really quite a fantastic sunrise, beautiful sky here in Verona, which makes a change from the fog. But
also in Rovigo, eh?
Yeah.
Yes,
did you get a good?
Yeah, dome. Yes, aurora.
Yeah, the dawn. Yeah, the aurora. It's the other aurora, not the aurora borealis or the aurora australis. But okay, so yeah, so I was looking at some stuff about clouds, and we've got this this thing that it's something that we just take for granted all the time. I think you just look at the sky and say, oh, yeah, it's cloudy or it's not cloudy, it's sunny, what have you. But there's a bit more to it than that, of course. And now we're in the winter. There are some sort of phenomena, atmospheric phenomena, particularly related to some types of clouds, such as the sundogs and the halos, which become a bit more common to see. So we've got different types of clouds. So we've got the classic cloud, the fluffy ones. So these are the cumulus. So we've got, these are the classic brilliant white clouds, which are sort of quite rounded, and how we describe as puffy, which is sort of like batuffaloso, if you like, and they tend to be a little bit darker underneath. But these are sort of typical fair weather clouds. Another type of cloud which is sort of found and at fairly low altitude. So these are below about 2,000 meters. So if you go up into the mountains, you can find yourself looking down on the tops of these clouds. Is the so-called stratocumulus, which are sorts of clouds which are they're similar to the cumulus, but they sort of they are more dispersed. Okay, there's more space between them, maybe. And then we have the stratus, which is this is when you have those low, what we call leaden skies. It looks like it's sort of just basically grey, and it's sort of quite closed. So these are three types of clouds which we find at low altitude. Then we've got the mid-altitude clouds, which are from between 2,000 to 7,000 meters. And again, some of these are, they occur only at certain times in the year, or they occur in certain seasons. We have the Alta Cumulus, which this, from when I grew up, where I grew up, this was actually quite common. Because it was to do with the weather patterns in the North Sea. You get this a lot, and what you have is you have small patches which it looks like you have lines of clouds, and you have lots of these lines across the sky, and so the whole thing looks like what we used to call mackerel sky, or the mackerel pattern, because it looks like the scales of a fish. We've then got what we call altostratus, which are sort of when the sun is. These are clouds which cover the sun very well, but you can see the sun, but the sun is not strong enough to cast shadows. And then we've got the nimbostratus, which are the big clouds which block out the sun and are typical of rain and bad weather. Okay, and then we've got the last set of clouds, which are the high altitude clouds, which are, I'm just going to take that down a little bit. Okay, so you've got the cumulonimbus. These are those big columns that you see if you ever drive across the Pianura towards the mountains in the late summer, and you see the clouds building up over the mountains. You'll see these. They're quite common when there's stormy weather coming. They look like cumulus clouds, but they're much bigger, and the tops always look a little bit like cauliflowers, or sometimes they flatten out into the classic shape of the anvil, which is the incudine. Okay, and they're typically associated with extreme weather in terms of storms. We have the cirrus, which are the wispy clouds. These are made of ice crystals that appear to streak across the sky. These are very high. The cirrocumulus, which are sort of like cumulus, but they are patches of ice crystals. But they look a bit like the mackerel skies that we saw on this one, but they're much higher. Okay, and then we've got the cirrostratus, which are transparent whitish clouds, let's say a very thin veil. This is typical of winter weather, when you have these sort of veiled skies. Okay, so now I realize that these are drawings, and so we have to, there's a certain, let's say, level of artistic license, because I haven't had time to take the photographs. But I think some of them, at least I think, are recognizable. So this is another one of those sort of matching, try to match the different types of clouds based on where you can find them in the atmosphere, in the troposphere, based on their altitude. So, Gloria, do you fancy having a go?
I don't remember any of them.
What about the obvious one? This guy.
That was not that obvious.
It's the cloud. It's the cloud that looks like a cloud.
Yeah, I know, but the name doesn't sound like cloud. Is it with C? Isn't it?
It's a what? Yeah, it begins with C.
With C?
It begins with a C.
Cirrus? No.
Okay. Rosella, what do you think? You see, this is the sort of, Gloria, this is the sort of exercise that you would do around the table in the class, or you do it at the board, and it would just create complete chaos in a classroom because everyone's sort of shouting and trying to remember what was what. Okay, but that's the advantage of internet. It's a little bit more civilized.
Yeah, unless they're adults, actually. So.
Well, adults can get quite feisty sometimes too.
Maybe that's a cumulus. No, it's a cirrus.
Okay. It looks like this guy. I'll tell you what. I'm going to reload the page. This is, as I say, this is teething trouble, which I hadn't realised would, because I tested this on a different computer. So it could be something to do with the browser, the way the browser is set up. But anyway, okay, cumulus. Let's say it is cumulus. Rosella, what do you think?
Hey, the cirrus in on the left, but
okay.
Okay.
This one. Okay.
Yes.
Right. Do you want to try another one while you're there?
Okay. The cirrostratus.
Okay, cirrostratus. Here we go.
In the high part of the picture, but not the spot.
It's this one.
Yes.
Okay, like the stripes. Okay.
Let's see, like
right.
that.
Okay. Livio, do you fancy having a go with one of the two of them?
So between cirrus and cirrostratus, we have Cumulus.
Okay.
On the right, we have the very high one, the very thick one.
This one
is Cumulonimbus.
Okay, right. Okay, I'm going to stop you there. And Marina, are you able to talk, or are you microphone? Maybe no. Just shake your head. See, no. Non ti sentiamo. No. Equity.
I'm able to listen, but not
talk. Okay, fine, fine. Speak.
Because I'm on journey.
Okay, nessun problema. Okay, Anna.
Yes.
Okay, so
it's a difficult garden.
No, they're not particularly fantastic drawings, I think.
Maybe between Cumulus and Cumulus, Alta Cumulus.
Ah, okay, yeah. Yes, okay.
And then,
if you want, I tell you what, we'll ask Antonio because he looks like he's falling asleep.
Yeah, better. Thanks.
Okay, and on the left of Alta Cumulus, we have Nimbostratus, and yes, and on the right we have Altostratus.
Okay, right. Okay, good. So, Ivo.
I think stratus is on Yes, a bit on the left.
This one?
Yes, yes, yeah.
Okay. Okay, so by exclusion.
Yes, by exclusion, this. Okay, okay.
Okay, accendiamo. Shall we see what's... Oh, you guys are heroes.
Okay, okay.
Win. Okay.
By chance, my daughter wrote a book about this nuvolario.
No.
Yes,
Bello.
two weeks ago.
No. Atlante delle nuvole, ma che roba.
Yes.
Okay, hold on a minute. So what, and she wrote the book.
Yes.
So what's the title? Atlante delle nuvole?
Yes.
And what's her name?
Nuvolario.
Nuvolario. Che bello.
The editor is Nomos.
Okay, now I'm just making a note of this. Che bello.
In the bookshop only two weeks ago.
And her name is what's her name?
Sara Zambello.
Sara Zambello. Okay. Is she a meteorologist?
No.
Is she a photographer?
He's a passionate. He's a lover of the
clouds.
Yes.
Oh, fantastic! Excellent. That's nice.
But me, I'm not expert on this this topic.
It doesn't matter. It doesn't matter. Oh, okay. Now this. Now I'm just looking at the time because we've got about 3 minutes, and there is a crossword here, so maybe this is a little bit too much. I'll tell you what. I'm not going to sort of continue with this because this might take us a little bit too much time. But this is the sort of, let's say, the sort of exercise that if we were in a classroom, we could do together. So I think at that point, okay, I'm just going to close this now, and I think it's just time to say so Merry Christmas. Okay, so I hope it's not a cloudy Christmas. I hope it's a nice Christmas with a slightly nicer tree than this one.
Nice tree.
It needs a star on top, doesn't it? Okay, so we'll put a star on top, and we need to put it in a bucket or something.
We wish you Merry Christmas.
We wish you Merry Christmas. We wish you a Merry Christmas
and
Happy New Year. Okay, so thank you very much for your endless patience.
Thank you.
Thank you to you.
Also, as I explained at the beginning of this course, this is the first time I've done this type of thing for teachers. When I work with students, I do completely different stuff. I do laboratory stuff. We do modules based on very particular, let's say, scientific experiments and stuff. And this is a bit more. It's a bit more general, let's say, but the idea remains the same. It's an opportunity for people who are, maybe not so interested in language itself to actually practice a bit of the language, but in a subject that maybe they're more interested in. That's the idea. So So I'd like to thank you very much for your your attention, also, as I say, your patience, because I've been testing materials here, so it's ecco, basta. So if you could give Stefano some kind feedback, he may be interested in doing another session of this, these workshops. So,
For sure. Thank you.
Thank you.
Okay, so okay, just one last thing, just before I forget. If anybody does wish to contact me, of course you can get in touch with me via Stefano. But this is my email. Okay, so
okay.
I need to stop. Where is that? I'm not sure where the recording is happening somehow. But okay, so as I say, thank you very much for your attention, and I hope everyone has a good Christmas and stay safe. And let's hope that the new year is a little bit, well, not just a little bit. Let's hope it's better than this one. Okay.
Thank you. Hope to see you in any other situation.
Thank you.
Okay. Thank you very much. Okay. Right.
Yes. Happy Christmas, everyone. To everyone.
Okay. Thank you, Sal. It's okay. It's been nice meeting you all. Okay. I'm going to